So you can see that adding or subtracting a constant will cause the line to shift upwards or downwards, depending on Welcome back to our coordinate geometry series. This is episode 2, where we will be looking at how to describe any straight line using its equation, right? So we're going to find the equation of any straight line. Now, in episode 1, we were just looking at how to write or find the equation of horizontal and vertical lines. Now, these are some of the horizontal and vertical lines we looked at as examples. Now, given that they are vertical and horizontal, what this implies is that we can describe either variable in terms of just one single constant, depending on how high the horizontal line is, or depending on how far to the left or to the right our vertical line is. So as an example, this green line here, we have a horizontal line, which means there's no change in the y-coordinate because it's flat, okay? The whole line is at a fixed height. So therefore, we can simply define the line by equating the y-coordinate to the constant 2, given that the line is situated at y equals 2. Similarly, we can do the same for this pink line, right? So the height of this pink line is at y equals 5. This is true everywhere on the line. So given that this holds true for every point on the line, we can define the line as the line y equals minus 5. Then we had a similar situation for these vertical lines here. So for the vertical lines, it's the x-coordinate that's not changing. So you can see this red line goes through all points of y in this domain, whereas for the x-coordinates, it's just going through minus 3. Okay, so we can define it as the line of x equals minus 3, and similarly for this orange line we can define this as x equals 9 because the x position of the line is at x equals 9. So now we're going to take a look at lines which are not necessarily horizontal or vertical. So here we're going to introduce the general equation of a straight line. So you may or may not have come across this. If you have, you'll know that we can write y equals mx plus c, where m and c can just be some arbitrary constants. Now let's start by comparing the lines that we've already drawn, or the equations of the lines that we've already drawn, to the general equation, right? So let's take our y equals 2 and let's see how that corresponds to the general form. So let's just write the green lines equation underneath, y equals 2. Now what you'll notice here is that the general form of the equation has this x term here, and it also has a constant term, given that m and c will take on constant values. So y equals 2 would imply that our m value must be 0, okay? So 0x plus 2, and our c value is 2. Now we're going to consider what happens to a line when we have a non-zero coefficient of x, that is a non-zero x term in the equation. Okay, so let's take a look at a simple example of what such a line will look like. Here we have a line which is neither horizontal nor vertical, so we're going to try to see how we might be able to describe this line using its equation. Now, as before, to do that, we're just going to consider the coordinates of some random points on the line, 1, 2, and 3 points here. Now, if we think about what the coordinates of each of these points are, this will give us some idea of how we can define this line using a relation between the x and the y coordinates Now, looking at this first point here, we can see that the coordinates of this point are 5 in the x and 5 in the y. Okay, so we have 5, 5. Now this point here is 2, 2. And this point here we can see is -2, -2. So now we need to think about what relation we can draw between the x and the y for these 3 points. That is, x is equal to y. Okay, so we can define this line by the relation or the equation y equals x, because all of the points on the line have this relation. So for all points in this domain for which the x coordinate is equal to the y coordinate, this will map this line of y equals x. Comparing the equation of the line of y equals x with the general form, we can evaluate the values of m and c. So if I was to write this more explicitly with a coefficient of 1 behind x and add a constant value of 0, we can then easily see that our m value is 1 and our c value is 0. Now what we'll do is we'll see what happens to the line if we change these values. So let's just start by changing the c value and see what happens to our line. Here we've just added a constant value 2 to the right hand side. So this time we have y equals x plus 2. Now what that's done is that it's changed the relation between the x and the y coordinates on the line. So for example, if we take this point here, we can see that the coordinates of this point are 3, 5. Okay, so the x coordinate is 3 and the y coordinate is x plus 2. So if x is 3, y is 3 plus 2, which is 5. So if we just input values of x from -10 to 10, the corresponding values of y will map out this line of y equals x plus 2. So you can see that adding or subtracting a constant will cause the line to shift upwards or downwards, depending on if we are adding or subtracting. Okay, so if the value is positive, the line will move up, and if it's negative, the line moves down. Let's try a couple more values just to see what that would look like. So here we are subtracting 4, which means every point on the line has a relation such that the x coordinate is 4 more than the y coordinate. Now if we take the point where x is equal to 0, then when x is 0, y is equal to 0 minus 4, so y is equal to -4. What that means is that the constant that we are adding corresponds to the y-intercept of the straight line. And this is true for all cases. So this constant value here corresponds to the y-intercept. Join me in the next video where we'll see how a straight line is affected by the value of m in the straight line equation. See you soon.